Hello, everyone. Thank you for invitation for about this conference. It's my honor to join the conference of data science and also the computing. And this conference is very important and very necessary for our research. So today the topic about my research is about the neuromorphic computing for smart agriculture. Firstly, I will introduce myself for you. I'm Xinqing Xiao from China Agricultural University, College of Engineering. And I'm now also the top research topic is about smart sensing. For example, the wireless, battery, and self-powered energy harvest smart sensing for food or for agricultural monitoring. And also my research about the Internet of Things and also the AI. So now this is about some research about this topic. And first I will introduce about the neuromorphic computing for smart agriculture. This is an article that we have already published in agriculture. And now I will introduce about this work. Now we have do and also we have review about some studies about the research. Further, I will introduce some about the neuromorphic computing because, as we know, the AI and also the computing methods have many different kinds of methods. But the neuromorphic computing is a new method for the computing about the sensing data and also for the different kinds of situations. So neuromorphics has received more and more attention recently since it can process information and interact with the world like the human brain. So it's not like the traditional AI method and also the AI models. The AI and also the Internet of Things and also the computers, they have need the semiconductor industry for the limit of ability to the computer chips, because as we know the chip. And also this is we call the conventional computing. So this computing is based on the von Neumann architecture where the data computing and the storage are separated. So this is not very fast, and also they will have need more energy consumption because the separated architecture. So the new computing has been proposed because the neuromorphic computing is still based on the structure and working mode of the human brain to achieve highly parallel computing based on the hardware. So this method can be realized low cost and also energy competitive AI computing in comparison with conventional computing. So this can be a new method and a new computing method for the future artificial neural networks. We can call it AAN and also the CNN and also SNN to perform the computation task. So this is the new computing. So based on the advantage of the neuromorphic computing, we have proposed over the architecture about this computing method for the smart agriculture. For example, we can see here, there are many data and many sensor data need to be acquired or collected in the situations. For example, we can need to use drones, wireless technologies, and also the farming, and also for the plants, crops, and also the food. So there are many different kinds of sensors like temperature, humidity, and also soil parameters, and about the quality and the safety about the food. So they will have a really much, very large data for processing. So based on the neuromorphic computing as the human brain, so we can know if we want to use the neuromorphic computing to the smart agriculture, we need use such as the tactile, visual, auditory, olfactory, and gestury, and these 5 things like human to monitoring for sensors such as humidity, temperature, light, sound, and gas. So they can have such as the input for the artificial snaps, just like the denture in biology computing. And also we need to generate the spike for the artificial neuron, or maybe we can call it neuron just in human brain. And then we have the data to the neuron and the neuron for a next step for just like a neural network. So for human brain, we have a biology neural network. But if we want to use to for computing in smart agriculture, we need an artificial neural network. So this is the overall architecture for the neural computing, neuromorphic computing in smart agriculture. Just we have shown for you, and we know it. We can process data with this, with more simple and more directly with the neuromorphic computing, just like the human brain. So inspired the high energy efficient biologic computing, so the neuromorphic computing in smart agriculture could be proposed. And these purpose just, for example, the parameters, humidity, temperature, and so on, they could be as the tactile, visual, auditory, olfactory, and also gustatory information in human biology system. So this system we can consist of the sensors, artificial snaps, artificial neurons, and also the artificial neural networks. So the sensors could sense the parameters in actual situations and then transfer it to the synapse and for spike encoding. And then the artificial neurons could receive the spike signals to the AI and for further process training, learning, and also computing, so that we can manage all the smart parameters with fast, local, low energy consumption, and improve all the production efficiency. So there are many different kinds of the, for example, the devices for the snaps. There are two kinds of. They are one is the two-terminal artificial snaps, and also the other is three-terminal artificial snaps. So about the two-terminal artificial snaps is there are 6 kinds of the different snaps. They are about the electrochemical materialization and the violent chains, phase chains, magnetic and ferroelectric and redox-based or negative synapse. The leads could be used for acquire the sensor data as the snaps spec signal. And the three-terminal optical snaps is about floating gate transistor and electric double layer transistor and electrochemical transistor and also ferroelectric field effect transistor. So they use the transistor as the three-terminal snaps. So they could also acquire the sense data as a spec for the neurons. About the artificial neurons, we can use about, for example, also many about the 5 kinds of the different kinds of neuron, artificial neurons we can make. So they could be used memory resistors, phase change, MOSFET, magnetic internal junction, and also ferroelectric neurons. They have different kinds of the principles, such as the specs in and the specs out, and also they will have different kinds of the spec signals outside. So based on the neural specs, so we can for further to get AI artificial neural networks to consider this network by these spec signals. And based on the signals from the neurons, so we can know that we can just use this instead with the AI to consistent of the networks. For example, we have 4 kinds of the different kinds of the network. For example, the picture A is about the traditional without non-spec artificial neural networks. So this is very normal for our AI computing. It's the same as the principles. And about the second one, it's about the implementation of the non-spec AI. So this how to realize, because there are many synaptic ways, and also they have pre-neurons signals and also they will have a pulsar neurons with the current output. And about picture C is about spike neural networks. So this is X1 and X2 and X4 is just spikes from the neural pre-neuron, and then we have the also synaptic webs with W1, W2, W3, and WM, and then the spike signals will transmit to the neurons. So this could be used as the spike and used for our neuromorphic computing with the spike signals. So this could be implementation about the thing with the picture D. So they could have a signal just with the snaps and with the pulse neurons. So the snaps with the spike signals just connect together, just could have a spike neural networks. So this is about the symmetric about the AM with the non-spike and with about the spike signal with the neural networks. So they are very important for consist of the artificial neural networks. So based on the artificial snaps and artificial neurons, and then based on the large networks about artificial neural networks, so we can use them into the computing about smart agriculture. So based on the previous introduction about our smart agriculture, we can regard as the temperature, humidity, and so on to as the 5 kinds of the, for example, the cycle and vision, just like humans. So based on this, we can have the artificial, for example, firstly, artificial visual system, just like human eyes. So we can get the human eyes with the image and to our brain, and we can know, oh, what is it, and what kind of the picture we can reconnect about them. So based on this, we can know artificial visual system for image process is also very important for our smart agriculture, because there are many kinds of the pictures and images that need to monitor. So how to use this image with the smart neuromorphic computing for our agriculture is very important. For example, the hyperspectral image processing and the connection with the neural conservation system could be built in the articles. And also about the RGB, bold image encoding and ejection by neuromorphic system could be also realized. So it's just examples from the previous work, just by the different kind of literatures. But I think in the future they will also be useful more normally if we can use these artificial snaps and neurons for our smart agriculture. It will be just brighter system in just like artificial visual system for the actual image processing, recognition, and also with the different kind of the AI methods. So this is just an example for artificial visual system. Another we can use, for example, the tactile system. Tactile just like our human hands. So we can got the human tactile systems. So we have many graphs and also many different kind of conductors for grab the fruits and grab the different kind of things. So based on this, we can use the artificial tag system for grasping, processing, and also reconnecting for our situation in the actual agriculture, just like how to use the different kind of machines for interact with our food or our plants. So this is just a human tag system based on this, and we can realize smart grasping and quality sensing for avocados, just like figure B. And also we can have a smart classification of different objects by the robotic grasping, just like pictures. And also we can with the artificial tag system, and we can use have some smart grasping and classification for kiwi fruit. and smart crayfish for apples, and also with the spiking time-based neurological system. So it's a very promising method. So by using this neuromorphic computing for our smart agriculture, especially for the grasping and also harvesting for the food. And we can have also harvesting it and with the same as the sensing with them, so we can know if it's quality very good and also not very good. So we can just have them together, just grasping and also sensing together, so we can know it's good or not. So based on this, and we could have all the artificial olfactory system for gas and recognition. There are many gases needed to recognize just in our smart agriculture situations. For example, the human health system, the snaps for the hydrogen sulfate. The hydrogen sulfate is also very important, so we need to use the olfactory synapse. And also we need to sensing it and also reconnecting to evaluate the friendliness of the, for example, eggs, food, and those groups. And also gas environments are the essential control and all the H3 response where visual olfactory model sensing could be used in our, for example, planting crops, breeding, and also smart farming, and also in the storage, and also for example, the transportation about the food. So gas is very important in our smart agriculture. So it's also very important to recognize sensing and recognize them with the smart method, and also we need to reconnect them with the smart computing methods and models. So the artificial olfactory system would be a promised way to about this and about sensing about the gases and also reconnect them by the computing methods. Another one is just like our human tongue, just we can know, oh, it's a different kind of the taste. So artificial gestural system for taste sensing and recognition is another application for in our smart agriculture. For example, we can use the spike neural network with a pH and also sodium sensitive neurons, and we can know the vinegar and the brain classification based on snaps post classes. So it's most about, for example, the chemical indicators in the for example in the fruits and in the different kind of food. So it's also very important in a smart agriculture for about the applications with the artificial gestural system for taste, sensing, and recognition. And also we can hear something. For example, we can have some sound, and we have some about the need to reconnect about different kind of acoustics and and sound, and also different kind of we can hear. So like the human here, we can have a artificial auditory system. So we can get the different acoustic signals and also receptors, just like snaps, and then we can have a processing to know what kind of the sound is from and how it will be processed in a smart agriculture. So just like this, we can have the different kind of situation. For example, we can have auxiliary signals transforming to synaptics reconnection, and we use, for example, the artificial neural network to computation and to processing, and now we can reconnect of different kind of the sounds and also acoustic waves. So based on the comparison with the neuromorphic computing and also with conventional computing, we can have the different kind of about the advantage or disadvantage. For example, for conventional computing, just like the just like AI computer with hardware storage and also MCU, so the hardware cost is high and energy consumption is high, and it's just for the computing mode, it's just serial computing. But the neuromorphic computing has a low cost of hardware, low consumption of the energy, and also they have a parallel computing, so the speed is very high, and the compute efficiency is very high, and also the different kind of adaptability would have high, and also the fault tolerance, logistics and logistic also would be really high. So the logic could be just further with the human connection. So by this combination, we can know that neuromorphic is computing permission computing method for the future, just like with the conventional computing. So as we know, conventional computing is also very popular now, but the neuromorphic computing is just developing, so it will be not very popular in now, and it just still need to development. So in the smart agriculture, the information computing and also now the AI computing, we can call them the conventional computing. This is just the step for the smart computing for the future. And in the future, the neuromorphic computing would be just like human, so it will be more deep for the computing in the future. So about the future development trends of the neuromorphic computing in smart agriculture, the neuromorphic computing would be implemented step by step with integration about conventional computing of the current information with Internet of Things, and also the upcoming AI computing methods. So the goal of the neuromorphic computing to improve the agricultural production efficiency and ensure the food quality and safety for human nutrition and health instrument in the future would be more and more promising methods. But as we know, it's just still developing, so it needs time. We needed more time to just develop this computing method for the future agriculture and the future smart things for the different kind of situations. So in the future, we can see that this neuromorphic computing just a new computing method now, but it will be progressing by use these methods if we can use them in the whole chain about the agricultural production, for example, the planting, breeding, and also the processing, storage, and also the transportation for all the food in our human life. So it will be just like a high efficiency computing methods. So this is just, I think, a different kind of computing methods just we needed to share with us about the, and also we can discuss about the future development if we use the neuromorphic computing. So they are just one step and step with about the different kinds of advanced technologies, so we can have a future bright and for the smart agriculture. Okay, so this is just about the simple introduction about the neuromorphic computer in our smart agriculture. Thank you.